Hello, everyone. Uh, my name is Dinorah. I'm Google Developer Expert on Android and also a mobile engineer in Confio, which is a startup in Mexico City. I'm located in Mexico. It's quite early. I'm sorry I cannot do this on person. I wish we could do it and grab a cup of coffee and talk about Android. But probably we can do it later on. Uh, so today we have a different talk. We have something about hosting the state, but it's solid basic on Compose. So first, let's talk a little bit about life cycles. And when I say life cycles, I mean everything that has a life cycle. It's quite common that a lot of things has a life cycle on Android, right? There we have things that goes over an activity, maybe a fragment. We have classes, and actually, well, there is a life cycle in Compose. All the composable functions has an entering stage of the composition. It goes over a recomposition when it's needed, and usually we have this way to leave the composition when we need to step away from it, right? So everything on Android has a life cycle, at least for the presentation layer. It's quite common. We need to be aware of this life cycle because it help us to build better apps and make something scalable and things like that. So remember things. Uh, Usually we want to have composable functions that are stateless, but you can have a stateful there. It's quite common. Usually for composable functions, if you push new data to the composable, you are gonna have something that is a new data, a redraw of the function, right? This part is called recomposition. This is only happening if the data has changed. So you need to be aware of this. Every time you call a function that is composable, if you don't emit the changes, you are not going to be able to see it, right? So every time you go and create a function, this will go for an initial composition, and then it will go for other recomposition, right? So like I was saying, composable functions work completely different because they emit data. Uh, and I don't know if that's the correct word to say that what is going to happen. I have a little animation in here. Imagine you have some data, maybe it's an int, maybe something really simple, right? And every time you want to push this data to your composable function, and you just send your data like normally you do on Android. And when you do this, your data is going to be put on your composable function, right? But the composable function has to go over a process that will be emit for the composition to actually see the change in the UI. So every time you do this, you're emitting the changes, especially because composables has memory of the position that is getting updated. Like every time you make an update, this composition remembers what happened last and if it's different of the position that we were having on the beginning. This is also known as positional memorization. Um, we are going to go a little bit over it to check what is going on actually with positional memorization. Uh, but that's pretty much the idea, you know? Every time you have a composable function, you are also trying to do the composition every time you emit and every time you get a new changes. As if data change to something that is a different int, this go to the composable function and will be do the composition. So first we need to talk about states and recomposition. Uh, States are pretty much everything. It's a quite abstract context. Um, States could be everything that change in your room databases. It can be an int. It can be the input that a user is putting on your keyboard. It can be a lot of things. So we need to be very careful when we talk about states, which because it's a really complex topic. It can be a live data that comes from an API. It could be a Rx Java function after a hard operation. Could be a flow. Could be just a string with the name of the user. It could be a lot of things. So we need to be very careful when we are talking about the state. They change over time. Why? Why it change over time? Because you need to be very explicit when you are talking about composable functions. You need to be told that there is a new state on the function. For example, if the user is writing their email in a form, the user is typing. So every time he's typing, we need to update the state of the view, right? So the reason is pretty much because we go over this process of recomposition. So we need to make sure that every time the data change, we do feedback to the view so the user can see actually something is changing. And obviously, the states can hold a value. And I was can be so this value, the state is actually holding the value, and from scope, go need to. Oh wow, my internet is quite unstable. Can you hear me? I think you can. So every time the states every time the composable function has something called recomposable scope, and it will be subscribed to changes of the value. So every time the state change, the recomposable scope will be in charge of hearing these updates, right? So at the end of the day, if a state can be anything, a state becomes an interface of that has any type of value. And if we have an state that can be an interface and holds any value, that means we can have an state that can be mutable. So we can have mutable state of, and we can create an observable of this mutable state of any type we have. So we can keep updating the data as we go. We ended up pushing the data to the view, maybe updating with the keyboard, everything that goes in between, right? And this looks something like this. Like, it's quite simple. It's just a mutable state of any type that extends the interface we were seeing, right? And we get the value. The value is going to be your an int, a live data, and a state flow. Everything that it goes in there can be mutable. So before we go over state and holding, we need to talk about a little bit about the initial composition and the recomposition. You not always go over recomposition. It depends if you need it. If the value has changed, you go to over this step. If it's not needed, we just cross our hands and we just say that we are staying with initial composition. And just to see it in a more specific graphic way, we have the first interaction. Maybe it's a keyboard interaction, maybe it's an API. And every time you go, you insert something in your UI, and then you have the composition, right? This is the first time you are doing the composition. If there is a second iteration, maybe we are inserting another letter in our keyboard, this insertion, we go over to do the composition and update the value that was already on the first composition. So every time you do a change, this is rewired pretty much. So the composition is stayed and maintained in the memory. So this actually depends of three little parts. We are not going to go really deep in here, and I know there is a lot of other parts of Compose that we need that are part of this process. But we are going to be talking about three today. The first one is compose runtime. The second one is slot table. I know there is a lot of confusion and a lot of comments about what is a slot table, if it's different to table contents, in what is actually doing, right? There is also a lot of people saying that the slot table is the gap buffer, and it's quite like that, but not exactly like gap buffer. Gap buffer is a data structure that is used for edit text, like for text editors like Word and Pages, um, but they go over something like that. And the last part we're going to be talking is about Composer, because Composer creates some types of nodes that we need to use for composable functions. So the first thing is compose runtime. Actually, compose runtime is a lot of things, but at the end of the day, it's the building blocks of Compose that give you a chance to interact with all the other two slots, right? Handle everything on the stage. So the little interface, the both interface that we were seeing a couple of slides ago, are actually part of the Compose runtime. And we need to talk about slot table. I know slot table has been talking about if it's a gap buffer or it's not, but it actually what it does is that it keeps the current state of the composition. It gives you a chance to update with every composition. If the data change, every time you have a change, it's put it in the array. If the value change, the array will be added and changed. Okay, so we have this thing about the gap buffer. The gap buffer is an array too that is used for text editors. This also means that you can add, remove, and update operations on your table, and it depends actually of how fast do you want to have these interactions. If you want to do it faster, you can use this type of data structure to access this data. And I have a little animation because actually gap buffer, it means positional memorization. That's actually the correct name that we should be using. So imagine you have an array. Maybe I'm not talking about compose exactly, but this is the general idea. Imagine you have an array, and in this array you are filling data at the beginning and maybe at the end because something happened. We don't care. It just ended up having something like this. So every time you push this, you are gonna end up having a gap of unused position in your array. So when you are start emitting and collecting this information, you ended up having your collection of the used A and the used B. The gap just stay there for any time you need to be used, and this will make sure that everything is going well. Um, for the part of the composer, I have a little example. I don't know if you have been using a constraint layout in Compose, but this little part is called inside. Multi-measure layout is a type of layout that is called on constraint layout. This is the code inside of it. And if you go over this code, like it's quite simple, right? It goes to a materializer, a density, and a layout direction. So it gives you hey, weight, density, and the orientation. And after that, you see a reusable compose node, and this is when everything gets quite fun, because reusable compose node, what it does actually is that is teaching the UI how to create a node. Is it is teaching, that means that reusable compose node remembers. So everything in compose is remembered around the interaction. So the information here of reusable compose node is that you invalidate the player, you start reusable the node. So every time that you have a constraint, it's gonna start learning how to insert, how to update, how to move around the tree of the composable. This is quite cool. So because we are going to be talking about remember the things that we are using, the values, the state, but we already know that Compose is gonna try to reuse nodes and try to use the current composer to make some changes and inserting and using the node. So this is quite cool. So let's talk about a little about the scopes of recomposition. Like I was saying, the composition is a state maintained by the memory. So actually, it's the big brain. It's the brain that is in charge of that everything is okay, that we can remember the value that we were putting, that we are not doing flaky UIs or something like that. This is the part when it gets interesting. So we have something called remember. Remember is a function that can store a single object in the memory, can be used in composable functions. Calculation to check if the value has been changed or is the first time we are using it. And this calculation will be evaluated during the composition and during the recomposition, okay? And will be, at the end of the day, we'll be returning the value to make sure that the meeting data and the view is updated with the last test value. So what is going on inside? You can use this with something like this function. This is a composable function and has three types of ways to access remember. Remember can be accessed over a buckle, a bar. The same value around it. And if you do this, we are going to focus only on this. In this part of the variable, we are going to have a bar variable that is going over remember, and remember is going to be a mutable state of a string. We might be thinking, okay, Dinorah, we don't have strings that might be updated quite often. We have APIs, we have room databases, and things are quite different in real applications. But we are going to get there, don't worry. This is just for a practical example. So if you go inside remember, what you are going to see is that remember has this function that goes to a calculation and has a cache, right? This function inside cache, what it does is the current composer will try to return the value by the provided of the lambda into the composition. And the invalid parameter force an update for the value regardless of being previously storage, right? So this is pretty much what it does. It's quite simple, but it does the trick. Inside of there is remember is the one that observes the stage, not the composable function. And we need to remember that because if you remember this animation, the data is pushed to the composable function, but we need to store it on the remember. We need to make sure that remember is least to come. So there's a question I got over this talk, and if remember store the value and has memory, does this mean that it will save us for activity recreation? Well, the short answer is no. But there is something you can do. There is something called remember savable. Remember savable is used to restore your UI state after an activity process. After the activity process is recreated. So if the life cycle changes, it can help you to restore that value, right? It retains the state across recomposition and also retains the state across the activity and everything that goes in there that can be poorly and goes really bad, right? So what is happening in here is that inside remember savable, we have a key. This key is the one provided by the user or the one generated by Compose runtime on this specific time. This is the final key that we might be using. And the part we go over all this code, and this code has a registry of where it's saving the data and remembers and try to consume the restored data if we can do it. If we cannot do it, well, it just go away. and in reality, we can use you can just remember savable. It depends on what you want to do with your UI. I would suggest you use this and make sure that you are using it constantly. Because at the end of the day, it will help you to dispose the values that you don't want to, or maybe the values that are missing, that maybe you ended up throwing away. So we need to remember that the composable function also has this life cycle. So every time you go to the end of your composable function, if you want to forget the remember, you need to make sure that you are telling the composable function, okay, this remember function, we don't longer want it, and we need to remove it. Okay, so let's go to the fun part. The fun part of the state hosting is actually state hosting taking in consideration that your views can be stateless, and you might want to have everything that is stateless, that is pretty much your UI, outside your variables. So this is not new. This is something that a lot of people have been using. For example, in React Native is a pattern of a declarative UI. And pretty much what you are doing is moving the state of the composable color to make the composable stateless. And if you are using, for example, any design system, this might make, this actually is the way to go. You make sure you move your variables, the remember variables that we were seeing, to the top level composable function, and pass them as an argument to each of the composable functions. And it's the same UI. Your designers are really good in reusing their designs, and they push the design system with these two functions, right? So every time you want to use this same UI, if you are doing a state hosting, so if you are moving your variables to the top level of the composable function, you can reuse this UI and this code. So this actually means that we are decoupling the code of the remember variables over the UI. So if you want to go like this, you are ended up having a composable func view that is going to be stateful. So you are attaching your UI to any change that might happen on the remember function. But you can do also this. You can have a composable function that is in charge of only your variables, and you can have a composable view that is in charge of your component. If we have this difference, we can make sure of a lot of things because you can make sure that you have a single source of truth. Imagine you are updating two UIs that are the same, and you are using two variables, two different variables, or remember, by moving the state instead of duplicating it, we are ensuring that the only one source of truth is the first function, the composable function, not the UI. So this helps us a lot. This makes sure that we are this might be the way to go, right? We are also making sure that we are encapsulating the stateful composables. If we need to have a variable that is exactly in a composable function that has the UI, we are making sure that this composable function is stateful. We are only access to them if we want to. it doesn't depend of variables that are external, maybe an API call or maybe an database call. We make sure that everything that is going on in there is only encapsulated to that function. We make sure that we are also sharing all the code. So if we are moving the variables to a top level composable function, and we are having the UI in another composable function, this means we can reuse and play with it everywhere. We can make sure that this UI is used in handling all the parts, right? So what it looks like in the code. So we are going to have actually two functions. We are going to have a view function that is going to have the variable that is remembered. And this function will have two values. The actual value that is called a name in this function. And we are going to have on a value change. On a value change, it could be anything, could be a lambda, could be anything that propagate a value change. And this inside this lambda, we are making sure to update the value as the value change. Value, the first part is in charge of the variables, and the part below that is in charge of the UI. You make sure to do really wait. We are separating everything in there. So what is going on is that we are going to have a. If we go with the first option, with the blue one, we are actually talking about stateful functions. We are talking about that the function knows the variables, knows the updates, and knows the code of the view. But if we are going with the second option makes sure that we have the composable font view, the view content, the UI, and we are making sure that we are talking to us over unidirectional data flows. So we go to a state and we update with an event. And it goes always like that. It's only a flow that we follow. We make sure that everything is decoupled, make sure that everything is handled in the right way. So that's quite cool. And there is something else we need to talk about. Stakeholders. Stakeholders are objects that manage complete UI state elements. We don't have just a string or just an int. Maybe we are using we are doing an application that has credit card information, and we have the credit card information, the time that the date the card is expired, and we have another information of the credit card, right? So our UIs are actually quite complex. They are not simple, or UIs are difficult to build. So when we are doing this, we make sure that having a stakeholder, we are making sure the UI elements and the UI logic depends of these objects, right? So we make sure that, for example, to have view models, objects, and pretty much anything we can imagine. We can have a data class, we can have a class, we can have a view model that goes over a use case, that goes over an API. That is a stakeholder, and it's a very broad topic. But at the end of the day, that's something that you push to your view, right? It's the object that you are emitting. Maybe it's an entity. Maybe it's something that you are just pushing to the view. So for that part, you might have this composable function, and a stakeholder that belongs maybe it's an object, a view model, whatever you want. Maybe it's a presenter, maybe it's something else. And this stakeholder is the one that is pushed from the view model over the presenter, right? So the view model or the presenter, or maybe a use case, is the way you access to your logic. And the stakeholder is going to be the object that is pushed from there, okay? So at the end of the day, you are going to have something that is a component state. Maybe it's a loading, maybe it's an error, maybe it's something like an update of the view with a successful process. And the composable will be only your UI component. only the UI, only the icon, maybe only the text, maybe only the animation. It's only your UI components. So your composition will happen over these two parts, your composable and your stakeholder. If we can divide these, we can make sure that we are also testing in a broad way on our UI. We can test the composable function to make sure everything is right, and we can test the stakeholder just by the stakeholder. And we can make sure that once they are joined, we are having the correct result. So at the end of the day, your stakeholder, your composable functions are in charge of meeting the changes to your UI elements. And the stakeholder will hold the view, the logic success, an error, and a loading. The stakeholder will be that select class. And the composable function will make sure that updating your UI and meeting everything that is going there, and that will do the trick. This will make sure that our UI in Jetpack Compose are scalable, and we are also making sure that is decoupled and probably is more testable and etc. Right? And I have one last thing to say, and that last thing to say is that maybe you are thinking, okay, Dinorah, that's really cool, that's quite cool, but I have like data that are pushing the values to the UI. Maybe I have Rx Java, or even that, or even like we have shard flows, right? For the first two ones, live data and change the value that you are pushing to your view and make sure that its wrapper are around an state. So you can start consuming it in a composable function. But for shard flow and state flow, the things change a little bit, because if we are not careful of how we are consuming that values, that flows, we might be having some troubles. And the reason is because state flow and shard flow collection is quite complex on the UI. We might not have fragments when we are using Compose, but we have activities. So we need to make sure that when we are collecting the state flow and the shard flow is going on the right way. If we miss something, we might be leaking, or maybe we are consuming too much memory of on the process. And this is not a lie. It's actually on the on the Google documentation of consuming flows. If you see here, is what is happening is that we are starting the consuming using launch when it started, and we are starting consuming we are consuming a flow, right? And when the coroutine is triggered, the collection is suspended, right? And the view goes, if the view goes to the background, we might have the underlying procedure active. So if this happens, we need to make sure that we are having a little job at the top. This little job, you might remember this structure from when view model didn't have a unclear, and we have this little job that will be collecting. We are going to add the job to the collection of this flow, right? So we are having this updating in here, and once the activity is done, we are going to go over a process when we are canceling this job. If we are not doing like this, we need to make sure that we are not leaking, or maybe we are not consuming a lot of memory. So this is awful, right? I mean, it looks great, it does the job, but I don't know, guys, if you have only one flow collecting in your view. I usually have like a lot. So you need to be very careful in here of how you are addressing this, because what you actually need is something that you can do automatically. You can launch and run in some specific stage. You do the collection of your flow within a specific stage. You need to have something that cancels when it's no longer on that stage, and you make sure that this is automatic. You so you don't depend of this code that you are adding at the beginning of your activity and then remove it once it's destroyed. So a couple of months ago, there was nothing like that. We have to go and do the job and then the on stop and do that over all our activities or maybe all over our fragments. And it was not the coolest thing ever, but we can do something now that is different. And if we do that with this new library, that is it's an alpha, but it works. I know it might be different, but this library makes sure that you can collect your state flow and your shard flow in a safe way. Um, you make sure that you are collecting using these two variables, repeat on life cycle and flow with life cycle. Repeat with life cycle will look something like this. You have a life cycle scope that usually is your activity or something like that. And you are going to launch the scope. Inside the scope, you are going to use repeat on life cycle, and you are maybe using on started, on resumed, or something like that. Once you do that, you can start collecting, and the collection will be safe. Okay. What is going on inside of here, and it looks pretty much a lot like a live data, is that what we are doing is making sure that the state of the view is not initialized or is not going on destroyed. Why? Because initialized on destroyed is not the right place to start collecting a flow. It's just the beginning of your life cycle. And this applies for a fragment, an activity, or whatever you want to have. We are setting up the main that we are going to have. We have a with context, and we are making sure that the life state is not destroyed again, and we go over that. Inside of this try catch, we have pretty much a way to access to the state, the life cycle of your activity. We make sure that the state is the correct place to start collecting. You actually have to give the name of the state you are going to start collecting, so you can make this little part. And once you go a little bit down of that state, it stop the collection. That's it. That's what it does, this little function. Make sure that everything is correct. It add the observer, and once the observer is added to the lifecycle event observer, and pretty much that's it. Once it's done, it's canceled, and we can remove the observer. For the other part, for the flow with life cycle, we have something like this. We have the same function. We have a life cycle that launch. We go to the state flow, the shard flow we want to collect, and we tell him what is the owner and what is the state we are going to start collecting. One is started, we are ready to go. So for this part, the code that is going on inside of here, it's quite the same actually, because it just repeat on life cycle. And what it does inside of here is that we are telling the UI which is the life cycle we want to address, and when we are going to address it. This state is the one. So the flow is going to use a callback flow, and inside a callback flow, at the end of the day, is a call flow. So it allows the elements to produce by the code that is running in a different context, so maybe concurrently. So this is something specific that you might need to use for some specific cases, maybe a channel or something like that. So you can use it with a callback flow. So at the end of the day, you are going to start using repeat on lifecycle, and we already saw what is going on inside of that code. So the collection will be safe. We are making sure the collection is happening only when the UI is active, or on the state we are telling in here. We are making sure that the collection of these flows is carefully curated. So we make sure that we are not using too much memory, we are not leaking, we don't have to use the job that might be adding the flow and removing it. And at the end of the day, you can also use it with Compose. So for the part of Compose, what we need to make sure is that every time maybe you have a view model and this view model goes to a use case, and this use case has an API connection or maybe a database connection, and you want to push all these flows to your view, and depending everything you are changing, you are pushing the data. So what you need to do is making sure to make sure what is your life cycle. Like I was saying, the composable functions also have a life cycle. So the life cycle owner is going to go and get the current uh, state of this life cycle, and we'll try to do a remember. So every time you go to a remember, you are going to put your flow inside this remember, and you are adding your lifecycle owner. So what is going to happen in here is that your composable function is going to start remember every change that might happen in your flow and emitting the changes when the flow is collecting the new changes depending of your life cycle. So with this, you make sure that your flows are life cycle awareness, that you are using a proper memory delegation, and that you are collecting safely. Okay, so you go over this, you go with a flow with life cycle, you put your life cycle in here and your stage when you are starting collect. And you can start using this little part that is collected as a state. You make sure that you are passing your flow to a state process, and this state is the thing that we can consume on composable. So you make sure that everything is okay and you are ready to go. Go actually a pattern that is using around declarative language around the world. So give it a try. It's quite cool. It will help us to have a more scalable UIs with composable, especially because inside composables you can have every function and maybe a lot of logic. So you make sure that with this you are separating the functions that you are remember over the functions that are based on your UI. It also opens the door to have design systems. And if you are using it correctly with shard flows and flows, maybe Eric Java or like data, you are making sure that actually you are consuming this in a safety way. So you make sure to cross all the good patterns that we might need on our UI. So give it a try. Give it a try. If you have any questions, you can ping me on Twitter and I will try to answer. And thank you so much for having me. I do hope we can do this in person maybe another time. And have an incredible day. I hope you have the best DroidCon ever.